So guys, let's try this second problem for similar polygons. So we have here Elio and Oliver on their summer vacation wanted to build a ladder for picking fruits in their family's orchard. So given the rough draft of the ladder here, okay, so this is the ladder, guys. It's this line segment, so that's AC. Okay, there we go. So that's line AC. That's gonna be our ladder for this problem, okay, that they built. And also we have a given here that triangle ABC, this big triangle here, is similar to the smaller triangle inside of ABC, so that's triangle ADE. And also we have the triangle ADE is congruent to angle B, given that triangle ADE or angle B is congruent to angle B, and DE is equal to 3 feet, and we have BC as X feet and AC as 16 feet for this one. And we also know that EC is equal to BC for this one. We need to find the length of BC, or the point or the distance between the ladder and the bent peach tree. Yeah, so this is point B, and this is where the tree, okay, is standing, and this is C, where the ladder, okay, begins to climb up, okay, towards the tree. Okay, so for this problem, guys, how can we get the measurement of BC? How will we find the measurement of BC for this problem? Of course, we're going to be using the similar polygons, but what ratio or what proportion can we create? What proportion formula can we create for this problem? Okay, so for this one, since our first clue here has been given, triangle ABC is similar to triangle ADE, we can say that side measurement DE all over side measurement BC, okay, should be equal. It should be equal, since we know that this small triangle is similar to this big triangle. Therefore, their side measurements must be proportional to each other. Therefore, the counterpart of DE would be AE all over, okay, the total measurement of the bigger side here, so that's gonna be AC. But for this problem, guys, we have another issue or another problem. We don't know the value of AE, but what we do know is the value of AC. It's equal to 16 feet, and we also know that the value of AC is equal to 16 feet, and we know that the value of EC is equal to X feet. Okay, so for this problem, we can say that since AE is equal to AE plus EC, and we know that AE is equal to 16 feet, okay, so that's gonna be 16 is equal to, okay, so that's gonna be equal to X. Okay, we don't know the value of X, and then we know that the value of EC is equal to okay, we know that the value of EC is equal to X for this one. We're just gonna transfer X on the other side. That should give us 16 minus X for the value of AE. Okay, so that's gonna be AE is equal to 16 minus X. We just removed the X from the 16, the total length of the ladder for the peach tree, and we're going to get the value of AE. Okay, and since we know that the value of EC is equal to X, that's been given, okay, we managed to solve for the value of AE. Okay, and also for this one, since AC is equal to 16, therefore we can write our complete formula for this one. So DE is gonna be 3 all over X, and that's gonna be equal to AE, which is equal to 16 minus X all over AC, which is equal to 16. And if we're going to write this proportion much cleaner on the other side, so this is gonna be 3 all over X is equal to 16 minus X all over 16. Using the extreme means property, ratio property, or cross multiplication, we can say that 48 is equal to, yeah, 16 times 3, so that's 48. That's gonna be equal to X times 16 minus X, and this is gonna give us a quadratic term. Okay, so that's gonna be 16x minus x squared. Okay, and if we transfer x squared to the other side and 16x to the other side as well, this is gonna give us x squared minus 16x plus 48 is equal to 0. And therefore, we have a trinomial that we can factor in order to find the value of x. So for this one, the best factor, okay, the best factor could be, okay, so let's try. Okay, so for this one, okay, let's try. Okay, let's try 12 and 4. Okay, let's try 12 and 4. So if we try both 12 and 4, so that's gonna be x minus 12, and this is gonna be x minus 4. That's gonna be equal to 0. So let's check. So it's negative 12 times x, that's gonna give us negative 12x, and negative 4 times x, that's gonna give us negative 4x. And what's negative 12 plus negative 4? That should give you negative 16x, which is our middle term, okay, our second term on this trinomial. And then what's negative 12 times 4? That's gonna give you positive 48. And therefore, we have two possible answers. So x can be equal to 12, and the other value of x could be equal to 4. But which is the best answer between 12 and 4? So let's check. Okay, for this one, let's say for example this is going to be 3. Okay, so therefore this should be, okay, this should be 4, and this should be 4, but this one should be longer. Okay, so it's gonna look like this. So this side is gonna be 12. Okay, so that's one illustration. Another illustration would be that this would be 3. Okay, and okay, this would be, okay, for this one, okay, if x is equal to 12, so this is going to be 12, and this is going to be 12, and this is going to be 4. So that's another illustration of the problem. But we got the two solutions. Okay, we got these two solutions based from the factored quadratic equation that we had earlier, which was x squared minus 16x plus 48 is equal to 0. And when we factored it, we got x minus 4 and x minus 12. And if we equate both answers to 0, okay, so we're gonna get that both correct solutions for this one. X is equal to 4 and x is equal to 12. And that's how we solve this problem.